Hello, coders. Good afternoon or good morning, depending on where you are in the world, of course. It is episode 206, and it is the 2nd of November 2024. I hope everybody's well. I've had an incredibly busy few weeks. My cold is still there, but we will progress through. The topics I want to talk today about are database schemas. We're going to talk a little bit about that. I've got an explainer video as to what database schemas are, but also I wanted to talk about PHP Tutorials, the changes that are on howtocodewell.net at the moment, some plans that I've got in the future, and also I wanted to discuss the Mac Mini that's just been released, the M4, because that's making me feel a little bit confused as to what its purpose could actually be from a developer's standpoint. And I wonder if anybody has any ideas and opinions themselves as to where that sits in the developer landscape, in the software developer landscapes. As always, this is a live stream, this is a live show, and so there you may hear the dogs bark and you may see me cough and splutter. I do apologize. When this does go on the podcasts in the audio form, I will be cleaning up the audio, trying to make myself sound a little bit more healthier. And so just be aware that we have, and I'm making this point a little bit more today because unfortunately we've had some problems with our dogs. We've got two dogs. We've got an English Springer Spaniel. We've got two English Springer Spaniels. One's called Murphy and one's called Goose. And unfortunately, they are both suffering. Goose had to go to the doggy hospital and have stitches, and Murphy unfortunately has an ear infection. So they're both not very well. So you may hear them in the background. I'm just going to put that caveat out there. So I may have to pause the stream and check on them from time to time. That being said, let's crack on and get into the Mac stuff, right? Because this is, I put out a tweet saying that this isn't great for developers, the Mac Mini, primarily because of the costing and primarily because of the base model specifications. But now I'm starting to get a little bit confused as to my stance is changing somewhat. So I'm going to just head over to the browser here, and we're going to go to this site, the Macworld site, and we're going to discuss the specifications. The M4 Mac Mini it's an interesting device, the Mac Mini, because it doesn't have a screen. It doesn't have a keyboard. Any of those kind of external devices you have to get yourself, which means that once you have the Mac Mini, you've already bought those things, which means that when the next refresh comes out, you already have those things. And so it's almost like you're doing a refresh yourself, and the screen that you've got, you don't have to change. And the keyboard that you've obviously got used to it. You don't have to change that. Same with the mouse, which means that there is the smallest amount of customization that you can actually give yourself, because you obviously can't customize the Mac. Once you've bought it, right? So you can't change the internals of anything, but you can change the externals. You can obviously change the screen. My concern with this is the price. The price is set to, as we can see on this site here, the Macworld site here, it's set to $599 or £599 if you're in the UK, of course. And it's starting with, which I think this is a crime, 256 gigabytes of an SSD, right? 256, and 16 gigabytes of unified memory. Okay, so the storage is incredibly small. I don't know why 256 gigs is even an acceptable option these days, and 16 gigabytes of RAM is on the cusp of just being usable for developers, in my opinion. That is painful. That price is so expensive. You can obviously upgrade this, and you can go for the Pro model, which has the 24 gigabytes of RAM, and you can upgrade the CPUs and whatnot. But you're talking about a hell of a lot of price for something that doesn't have a screen. And when you start moving into that territory, then you're thinking, well, why don't I just get a laptop for that? Okay, so I applaud the fact that we're now on 16 gigabytes of RAM, but I really do think that in this day and age, we should be on at least 24. The Mac Mini that I'm running, the MacBook Pro that I have here is 64 gigs of RAM. It's proper future-proofed. And I did that because of all the things that I do, the video recording for one, as well as the Docker, having multiple instances of various things running. It's just having that headroom really does make me feel more confident that this is going to last for years and years and years. Now, I'm not saying that everyone needs to have 64 gigs of RAM, no, certainly not. But 16 gigs is just the bare minimum. I can give Docker 16 gigs of RAM and not feel it. And yes, there have been many projects where 16 gigs of RAM is required. And we're not even talking about, like, we haven't even spoken yet about what the operating system consumes. And so when you're looking at these specs, you've really got to take at least a third off for that kind of stuff. You know, what is your app going to be? What are you going to be doing on your daily driver? You know, if you're just in WordPress, in like Word or Numbers or whatever they call it, Pages, I think. If you're just in that all day, then fine. But for us devs, when we've got things like Visual Studio Code running, when we've got several tens, if not hundreds of tabs running in Chrome, if we've got Docker containers spinning up and spinning down, if we're doing some really hard computational tasks, then this is 16 gigs of RAM doesn't really cut it, in my opinion. But I then slept on that idea and that thought, and then I woke up and then I thought, well, actually, this instead of seeing the Mac Mini as a machine where we can do all the things, right? Think of it like having the Mac Mini where we can do one thing and one thing well. So maybe we could use this as a build server. Maybe we could stick Jenkins on this and have this as a headless box sat somewhere where we're pushing code to. Maybe we could also use this as a staging server. So maybe we could have access, internal access to a local host running on this site, on this box, and then that becomes our testing platform. Maybe we can throw some Cypress tests at this. And 16 gigs of RAM, yeah, we're starting to talk sense here. But when we're talking about actually developing code, trying experimenting code, on 16 gigs of RAM, I think that is too small. And I think 256 gigs of storage is just too tiny. It's tiny for a daily driver. So I don't think Mac Minis are for daily drivers, the base model. However, where it gets interesting is when we start talking about the Pro models, because now we're starting to add some more spec to this. And maybe I'm going to use this term, and I've never used this term before, and I hate it. I already hate it. I already dislike it. Developer hot desks. I can see I can see someone looking at this and going, we could give all of our developers exactly the same machine. We can give them some, they can choose maybe their screen and their keyboard and their mouse to make them happy, because developers need the clicky clacky noises of the keyboard and the soft scrolling of the fancy magic of the MX Master Mises, and maybe, this guy wants to have more screens. Well, we can do that with the Mac Mini, and we can have a universal sort of environment or device that we give all of our developers, which means that the overhead of securing those, of dealing with network issues and rolling out updates. Because we only have the one thing, it's not like half of our devs are on Windows, the other half of our devs are on Linux, and a couple of people sprinkled in are on Macs. It's now, we're just going to get the Pro model for all of our devs, and then when this refreshes, all we have to do is change the box out. So I can see people looking at this and going, this is interesting. Maybe we should provide our dev team the Pro model, and then all we have to do is replace that and not worry about other types of operating systems. Because I can see a lot of developer agencies saying, right, all of our devs are on this single operating system and this set of device throughout. I can see that, and I hate that. I hate that because there's no customization, and then there's no, I like the way my keyboard is. I like the way my screen is, and I like the way it's set up, personalized to me. But when you're working in big teams, it's best to have perhaps machines that are all the same, because then that's easier to update and roll that out. So I can kind of see this. I can also see this, as I mentioned, with the build servers and the staging boxes. However, so howtocodewell.net has its own sort of staging process, and when it's using GitLab, and so whenever I push changes to GitLab, depending on the pipeline which gets triggered, the certain tests get ran, and then also there is a pipeline that when I tag the latest release, the Docker image gets built and is ready and primed to be deployed. It's a bit of a manual process at the minute, but all of those things could happen on an external box. At the minute, they're all working off of this laptop, which is a bit sucky because it means that there's something going on in the background whilst I'm developing something different. So I can see palming that off to a Mac Mini may help. However, when we get to that stage, I don't see the benefit of being in the Apple ecosystem for build servers and staging servers, because there's Linux, man. Just use Linux, because you're going to be paying half of that, and you'll have the ability to customize the hard drive and the CPU and the RAM, and so it's going to be far more user friendly, or developer friendly, shall we say. You don't have to be, because it's headless box, because all you're doing is the build and the testing. You don't have to hook into any of the ecosystems. You're not going to be Bluetoothing your sound to that or anything daft with your Apple AirPods. There's nothing that you need apart from the fact that there might be, Jenkins running on that box, and that could be running on Linux. So, but there is another caveat to this, and that is mobile app developers. So I can see this being a fantastic product for even the base model for people who build iOS apps, and they need some form of intermediary server that does the build, does some testing, that kind of stuff. A bit like how we would use, say, Jenkins to test a site or run some Cypress tests. iOS developers would see this and go, this is very interesting. We could have this as a means of setting up a staging environment for our mobile applications, running some tests off of that kind of thing. Basically taking the process off of our local machines and palming it off onto something external. So I can really see how that would be a beneficial thing. But let's just, whilst we got this open, let's have a little look at it. So prices for the two standard Mac Minis have been reduced by £50, okay, in the UK compared to the previous generation. That, £50 off of a Mac thing really doesn't, 50 quid. Okay, fine. The M4 model costs the same in the UK, but that price rise in the US from $100 to $12.99 previously. It's expensive, man. It is. It's just expensive. Let's just be real. That's expensive. Upgrades are available at an extra cost. Of course they are, it's Apple. For example, the M2 Pro can be upgraded to a 14-core CPU and a 20-core GPU for $200 stroke pounds. Keep in mind that these prices do not include a display, keyboard, or mouse. This is the point. I don't think this is a very good starter model for people who want to get into the Mac world because they need to get all of this kit. This is primarily for people who already have this kit. You can provide your own, or you can buy them from Apple, of course you can. And then we start getting into the nitty-gritty stuff with the processor, the GPU, and the RAM. So the M4 has a 10-core CPU with 4 performance cores and 6 efficiency cores, and a 10-core GPU. Apple does not offer CPU or GPU core upgrade options with the M4. It's gonna be nice and quick. You know, it's a given. It's an M4. It also comes with 16 gigabytes of unified memory to start, upgradable at an extra cost of 24 gigabytes or 32 gigabytes. I don't know why they stopped at 32. Maybe it was a heat thing. Maybe it was a thermal thing. I don't know why they did that. The M2 Mac Mini started at 8 gigabytes of RAM, so the switch to 16 is a welcome update. It is, don't get me wrong, but by the time we need the next upgrade, like what's the next one, 24? By the time we get to that point, right, I don't know when that's going to happen, we're going to be seeing 16 gigabytes of RAM like we used to see 8 gigabytes of RAM. I don't know why they don't just start with the higher number. This is obviously not a pro machine, right? Okay, so this is interesting. Compared to the Intel i7 Mac Mini released in 2018, Apple claims the M4 offers 13.3 times faster gaming performance. I don't know why they're testing games on Macs, because that's just... But anyway, so 33 times faster image upscaling performance in Photomator, and applies 2.8 times more audio effect plugins in Logic Pro. Compared to the M1 Mac Mini released in 2020, Apple suggests that the M4 is 4.9 times faster when merging panoramic images in Adobe Lightroom Classic, 1.7 times faster with spreadsheet calculations, get you Excel, in Microsoft Excel, and 2 times faster when transcribing on-device AI speech-to-text in Mac Whisper. I've never used Mac Whisper before. I've heard of it, but I've never used it. So yeah, I mean, it's quick. It's quick, but is it worth the upgrade if you've got an M3? Probably not. You know, probably not. Or if you've got an M1, probably not. I mean, if you're already on an old M1 Mac Mini, you're probably looking at this thinking, well, I'm going to need at least 24 gigs because there's no point in upgrading my M1 8 gig to 16 gig. You're probably going to be looking at 24, right? Which means that you're going to be paying a lot of money. Anyway, the M4 Pro has 12-core CPU with 8 performance cores and 4 efficiency cores and 16 gigs of GPU. Apple also offers the M4 Pro upgrade to a 14-core, 14-core and a 20-core GPU for $200, 200 pounds. The M4 Pro Mac Mini comes with 24 gigabytes of unified memory to start with, which can be upgraded to 48 or 64. So this is what I would be playing with, the M4 Mac Mini Pro. But again, it's so goddamn expensive for what that is and for what I need. So when people look to purchase the Mac Mini, they really need to consider what it is that they're actually doing. And they have to accept the fact that they are locking themselves in, because it'll be like, okay, we've now got a separate screen and we've now got keyboards and mice that we're so used to, that when we upgrade again, we need to make the decision that if we don't go for a Mac Mini, we're probably going to go for something completely different, which may already have screens. We may be going for perhaps a laptop if that's what we need, which means that the other things, the screen and the keyboard and the mouse, is now redundant. So there's decisions. There's decisions. And the screen that I've got is huge. That's a bit of a commitment to get rid of. Anyway, excuse me. So that's my concerns with the M4 Mac Mini. I don't think 16 gigs of RAM is enough to begin with. But the problem is when you start moving ever so far into the 24, 32 or 64, you're playing with big numbers. And it doesn't make any sense to me to get one. I'm in a weird position, you see, where I have my old Mac Mini, which isn't, by the way, an M chip. It is the last Intel chip that they made. That now is so slow to do any video editing on it that I've basically just left that. And that is now going to probably be my deployment build server, GitLab pipeline thing, testing, staging build server, which to me feels very daft because it's a very expensive thing to do that. I may as well just get a Linux box, I think, but I don't like waste, so I'm going to probably use that as that thing. But it's one of those where I don't recommend people do it because it's very expensive. If you don't have to buy a Mac 4 Mini and you are looking to build a build server, then there are so many better options out there for you. Just go with Linux. Anyway, all right, we're going to move on now. We're going to start talking about, go back into the browser here. We're going to start talking about some PHP courses that I've created. Woohoo! Last week, as I've mentioned, last week and the week before, have been so busy, so busy. We now have a programming courses podcast tutorials and articles section on the website, so howtocodewell.net. We have the podcast on the left hand side and the tutorials and articles on the right hand side, and these are the articles that I have been writing up, the tutorials, sorry. So we've started on PHP, but I am going to progress into other programming languages. So the first one that I've got here is the Laravel SSH build. We'll start from the bottom and work our way up. The first one then is the build and deploy your first Laravel API. So if I click into here, all of these links, by the way, are in the show notes below. In this tutorial, we will build an API Laravel in this tutorial, we'll build an API using Laravel and the API platform. After this application is built and configured, we will then deploy the application to a Cloudways VPS. So this is a tutorial. I believe it's almost 20 minutes long. It's quite thorough, where I talk about how to actually build a Laravel API from ground up using all sorts of composer tricks and whatnot. And then how do I deploy this to a Cloudways VPS? Now, Cloudways is a sponsor of How to Code Well, and they have provided me with a server that I can push this stuff to. And they've also kindly, as they've sponsored this tutorial, they've given a 20% off Cloudways, 20% off, your first Cloudways web hosting subscription. Which is pretty awesome. Cloudways is a handy dandy web host for choosing various different other VPS providers, right? So you can choose, say, DigitalOcean, or you can choose AWS, or there's Google on there too, and others. So if you wanted to choose your VPS provider, you can use Cloudways to do that, which is pretty awesome. So we go through the installation process, how to install the API, how to create the migrations using migration files in Artisan, and then how to actually create an API resource. So, and then after that, it's the deployment, the provisioning of the servers, bringing those servers up, SSHing onto them, and then installing the application onto the VPS. So that was the first tutorial that I wrote. The second one was how to concatenate PHP strings. So normally technically there's a way to do it, but there's actually more than one for PHP. So I started by talking about what concatenation actually means in programming, and then I demonstrated the standard way of doing concatenation. And then after that, I discussed the short syntax, string interpolation, imploding an array of strings. I also provided two examples, one for the twig. So if you want to learn how to concatenate strings in twig, which is something that I always get wrong, then I provided that here. And I've also added a blade example too. So that's the second tutorial. The third tutorial was this one. This is a question that happens a lot with PHP, when to use the various different control structures, be it switch or an if statement or a match statement. So when do you actually use those? So the first one is just an example of a switch statement, right? A standard switch statement. And then after that, we have that, but in the match statement form. And then we have a discussion of when to use a PHP statement. So we've got an example of that there. And I've got some, some pointers of when you would use an if statement compared to a switch or a match. But then what I've done underneath, which I love doing this. I found this very fun. What we did is we got the switch statement and we turned that into a match statement. Excuse me. And the way I did that is I did some clever refactoring of the switch statement, where the switch statement was dealing with classes. So we had a student parent, and a teacher. And if your user type fell into those things, then certain actions would be performed, certain methods would be called on those classes, and then after that we would call get name to return the name of the user, I suppose. But I wanted to demonstrate how to break this up into a match statement, because I see this all the time, right? We've got this huge chunk of switchness, and then inside the cases there might be if statements as well, which is just not fun. So what I did is I started demonstrating the classes themselves. So teacher class, a student class, student parent class. So sort of a pseudo code as to what that is. And then I extended that, created an abstract class, which they all extended to get the name back. But then I created a user interface that all of these classes implement. And then if I scroll down, we can see that we've got the match statement here. And the match statement is now instantiating the relevant classes and then calling an update method. That update method is within each of these classes that then performs the actions, which means that we've now decoupled the whole process from the switch statement, which is up here, right? The calling of these methods no longer is bound and coupled to the switch. In each case, we are now just calling a single method called update, and that update then decides what other class methods to call, right? So this is I love doing this. When I see code that is a bit difficult to read, I love coming up with the architecture of how we can actually make this code more user-friendly, more readable, more extendable, because now it doesn't matter what is called in each of these cases. We just call update, right? We just call update, and then update decides what gets updated, what other methods get called specifically for each one of those classes. It's great. It's fantastic. It's just a sprinkle of architecture that I really do like to do on projects. Yeah. One thing I would say though is be careful when you do something like this, because you really need to add some tests on this to make sure that it's still doing what it was supposed to be doing before you made those changes, obviously. But yeah, it's a great example, I think, at least, of how we can extend classes into abstract classes, and how classes can implement a common interface, in this case the user interface, where we just have update and get name, right? Yeah, and it just makes the code, in my opinion, so much more easier to read and use, and is future-proof for later if we wanted to add different types of users. Then we could do that without having to worry about the actions that they perform within each of the cases. So there we go. That is the tutorial. Oh, sorry, no, there is one more tutorial. The last tutorial that I created was how to create a bash deployment script. This was fun. This is a tutorial where the Laravel API that we created in one of the previous tutorials now can be deployed automatically using a build script, using an SSH bash, using a bash script, which then I can push via an SSH tunnel. So I talked about how to actually create the bash script, the permissions, how to deal with the permissions on the bash script, and then right at the bottom here, how to SSH this up. This tutorial was also sponsored by Cloudways as well. So I demonstrated in the video of how we can create, well, SSH onto the VPS, create an SSH key on the VPS, and then take that key and then put that to GitHub as a deployment key. Configure Git, because you need to do that. So configuring how we do the pull on Git and making sure that the Git sees the directory on the VPS is safe. And then how we can clone the Git repository on the VPS, changing the environment variables, and then running the build script. And then after that, I showed how to run this in an SSH tunnel on your local machine. So you don't actually have to get onto the VPS and do those things manually, because you're going to change working directories and whatnot. The idea behind this tutorial was to demonstrate how to remove or reduce the amount of human error involved in actually running a build script. There is another tutorial coming up which is pretty interesting. It's going to be on GitHub Actions, which I'm really looking forward to, and we basically take this to the next level where we've got a CI/CD pipeline using GitHub Actions that does a ton of this awesome stuff. So yeah, that is basically what's happened in the How to Code Well world in the last 2 weeks. We have had a lot of content being added to the site. I can just see a bug there. That needs to be up there, doesn't it? Yeah, so that is so howtocodewell.net is the place to be if you want to learn these tutorials. These tutorials, by the way, that I've just mentioned, they're totally free. There's also paid courses up there as well, so if you want to learn Linux or learn some more PHP goodness, and there's also a Docker course on there too. Okay, so I would love to talk about database schemas today. That would be awesome. I'm gonna just take a drink though, because my throat is starting to get really bad, and then we'll talk about data schemas. Give me a sec whilst I do that. Okay, sorry about that. So I would love to talk about database schemas. In episode 205, so the previous episode, we talked about databases and what databases are. That show is available for the members. That will be released publicly in the next week or so. Same with this one when this goes out. Database schemas is a topic that is of interest to me, because I'm obviously building the howtocodewell.net site, and I'm constantly changing the schema, and there are some things that are coming down the line that I would like to perhaps use in a NoSQL kind of manner. So I want to finish today's show doing an explainer on what database schemas actually are. It's kind of like the next follow on from the previous episode where we were talking about what a database is. So I have some notes here that I want to discuss. So, okay, so what is a database schema? A database schema describes the structure of a database and is used to define how the database is constructed and how the data is organized. A database schema is written in a formal language such as SQL, which is used to describe tables, columns, constraints, fields, relationships, and more. So we talked about SQL last time. SQL, SQL, structured query language, and it's used for relational databases because it's structured. And with this, with the SQL, with the SQL, we can define how the tables are constructed and how they're organized using columns, constraints, fields, relationships, and more. And it's a way of basically creating a blueprint for your database. That's essentially it, right? If you think of schema, think of blueprint as well as access controls and whatnot. So once a key benefit of using and maintaining a database schema is to document how the database is structured. Database engineers and administrators can read the database schema and understand how the data is organized. So if you are a DBA, or if you know anything about databases, and web developers really should, they will be able to read a database schema and understand how the data is stored, how it's structured, the relationships between the data, without actually seeing the data. By just reading the database schema, they'll be able to see how the tables are laid out, what is connected to what, where are the keys, what kind of rules are in place for the data to be stored and to be queried, that kind of stuff. So without actually having any data in the database, a DBA will be able to do all of those kind of things when they read the schema, when they read the structured query language. So once the database has been structured using a database schema, the data becomes more accessible due to the data separation of tables and other logic structures. Information pulled from the database can then be siloed into data models. So what do I mean by this? So we could have a class that represents the table in the database. So here I'm kind of alluding to like an object relational model where we have our, if you're in the PHP world, for instance, you may have doctrine entities which represent the data in a table, and you can then use those to translate the raw data into an object in PHP, for instance. So I'll just say that again. Once the database has been structured using a database schema, the data becomes more accessible due to the data separation of tables and other logical structures. Information pulled from the database can then be siloed into models. I think what I'm going to do is I'll do an explainer like this where we talk about models, because there's more to it than that, right? In that sentence, there's more to models than just storing data. We can talk about the boundaries of where a model lies, where a model doesn't become a model anymore because it's something else. But anyway, that may be for another time. Database schemas also enforce data integrity as they set constraints, define required fields, data types, and relationships. This means that data administrators can be confident in the integrity of the data, as each transaction will adhere to rules and structures defined by the schema. So when you create your database schema, you are defining the constraints and the required fields, the data types of the data that are required for each of the tables and whatnot. And you are literally setting rules in place for, this data must have this. This data must be in this form, that kind of stuff. This data is linked to this data using this connection, that kind of, boundary setting there. So this means that database administrators can be confident in the integrity of the data, as each transaction will adhere to the rules and structure defined by the schema. So for example, you can't just insert any random record. You've got to insert a record that conforms to how the data needs to be stored, how the data is set out in the schema of the table. Like, for example, it has to have perhaps a first name. This person has to have a first name because it's not nullable. Or it has to have a bio, and that bio has to be less than this amount of characters, that kind of stuff. There has to be a tiny int that denotes whether or not it's active or not. There has to be a birth date, that kind of stuff. And this birth date needs to be in this format. So we are really getting quite rigid with how the data is enforced. As the data is stored in a consistent and structured manner, there can be compliance with acid tests. Now, we're not going to go down the acid tests rabbit hole today. We'll probably do it at some other point, but it means essentially that everything is kind of, as I mentioned, it's individual, it's siloed, it can be tested as a single thing. And then what I've got here, I'm going to just go over to this browser window here. Apologies for those listening, but what I'm doing at the minute is I'm just bringing up how to build a database schema showing Microsoft Ignite. This is a website here, and if we scroll down, we can actually see a schema in this form here, where we are creating a schema called sprockets. We're authorizing Joe, and we're creating a table called 9 prongs. These are the fields. We're also defining a data type for each one of these. So source is an int, cost is an int, part number is an int. And then we're dealing with some grants. So we're granting the access to Bob to select, and we're denying John the ability to select off of this as well. So this is an example of how we can create a schema that defines this table, and how we can actually limit the access as well. Sorry about that. I'm still quite chesty. Anyway, so in this example, we are defining a schema called sprockets and giving the user Joe authorization. A table called 9 prongs is created with the fields source, cost, and part number. Each field is designated a data type, and user access is defined. And then I have an example. Do I have this on here? No, I don't. Oh, okay. That's a shame. I thought I had a link to an example of MySQL. But MySQL, the SQL there, it is different, because we're no longer talking about MS SQL. We're talking about MySQL. But the structure of the way the language is laid out is very similar. So we create a table. We have a series of fields on that table, and those fields have a series of rules. We define their data types, and we define their constraints. We define how the char set, the foreign keys, all of that kind of stuff. We do that when we create the table, and when we create the table, we are creating the schema for that. Let's just go back to here for a minute. Okay, so that's a discussion on SQL, but what about NoSQL? Because does NoSQL have a database schema? Well, even though a non-relational database does not have a formal structure, it can still be defined as having a dynamic schema. A NoSQL schema will explain the structure of each document, and this can be altered for future documents. These future documents are held in the database, obviously. Excuse me. As NoSQL cannot include foreign keys, its schema doesn't define any relationships or constraints between the data. And what I'm going to do is I'll just demonstrate this. We'll go over to MongoDB, which is something that I've used before, which is a fantastic piece of kit for NoSQL. And this is an example of a schema here. So we're setting the const. Again, apologies for those listening. What I'm doing is I'm going to mongodb.com, and there is an example here of a database schema where we have a blog, and we're defining the structure of the blog. Obviously, it's going to be a very loose structure because it's NoSQL, where we've got things like the title, the slug, the published, the author, the content, the tags, the created dates, and the comments. So these are the fields, and we're also defining the data types of those fields. So title and slug, they are strings. Published is a Boolean. Author is a string. So is content. The tags, however, are a string within an array. So it's an array of strings. And the created and updated at are both dates. Now, the interesting thing comes when we get to the comments. The comments is actually an object of itself. It's an array of objects where we have the user and the content of the comment and the votes being a number, content being a string, and so is the user. But we have the ability to have multiple ones of those within this single schema. Now, if this was a structured query language, we would have a separate table called comments where we would have an ID for the blog in the comment. So we would say this comment has this blog ID. So this comment is for this blog, right? Whereas what we're doing here is we're saying, no, this blog is actually a document, and this document also contains all of its comments, which means that this document contains everything we need for this blog, including all of the things that are perhaps one could see from an SQL point of view as an external piece of data, i.e. the comments. Now, I have an interesting idea as to, let's just go back to this view. I've got an interesting idea as to what I could use NoSQL for in for How to Code Well, right? So, as you've seen, there's going to be lots of, as discussed, there's going to be lots of, let's think. Yeah, so an interesting idea that I've got for howtocodewell.net is recommendations of tutorials and courses based on what the user has previously seen, viewed, right? So I would need some form of way of capturing that, saying like this user has seen this course and has read this article and this tutorial and listened to this podcast, right? Off of the back of that, I could perhaps recommend different tutorials, different courses, different podcasts based on what the user has seen previously. Now, there's probably no reason for me to store all of this information in a structured query language in, say, MySQL, because this is very unique to the person, and it's not really going to offer me any kind of benefit in terms of any kind of analytics. However, it's certainly going to be tailored to the specific person. And if that data suddenly disappears, then it's not going to break the system, is it? So what I'm thinking is having some form of relation where this article has been suggested based on this podcast that was listened to, or this course that was listened to, and then I can perhaps see more from an analytical point of view. You know, maybe the users prefer these kind of tutorials. Maybe they want to lean more on JavaScript, and maybe these users perhaps more in terms of PHP or Docker. So that analytics could work, but in terms of how we capture that information per user, we could have a document like what I've just shown you in the MongoDB example, where we could have the user and we could define a schema that is very loose and can be adapted and can be updated every time they view a different piece of content. and it would basically become a recommendation engine. It's a recommendation engine essentially, but using a very fluid, dynamic storage engine, albeit, possibly MongoDB, maybe Redis, that kind of stuff, where that kind of information, if that gets stored in a SQL engine, a SQL database, essentially what I'm going to have is just a series of linker tables with a bunch of IDs. It's not really going to give me any kind of benefit to that. So that's an idea maybe of how I can use NoSQL on howtocodewell.net. But anyway, going back to this example of MongoDB, excuse me. So the example that I've just shown demonstrates and defines the properties of their data types for the blog document. I'll go back to that. Let's go back to the browser here. So we can see that the properties and their data types have been defined. And notice the schema is more flexible compared to SQL, compared to the SQL example that I showed you previously. A document's property can be a collection of other objects as shown by the comments, as I mentioned before. So in terms of, say, the How to Code Well thing, we would perhaps have user, and the user would have like recent articles, recent tutorials, recent podcasts, that kind of stuff. And then we could possibly have some way of in the background, like maybe if this gets all captured, and then in the background we then decide, well actually they are more PHP orientated, more JavaScript orientated, more Docker orientated. And so what I'm thinking is having like this storage where this gets populated, a collection of the recent articles, comments, and articles, tutorials, and courses, a collection of each one of these per user, right? And then we send that up to an API, and the API then comes back with recommendations or suggestions based on the collection, and the collection will be ever changing, and the suggestions will be ever improving. That is kind of my thought process of how I could use MongoDB in step with an API, which then returns suggestions. And I was thinking, like, how would I do this? Like, how am I going to suggest the user's new content? And I'm thinking, well, maybe we could do it by tagging content, PHP, JavaScript, tagging content, databases, that kind of stuff. And then I can then go through the collections and work out, well, they've looked at more PHP stuff. They've looked at more database stuff. They've looked at more JavaScript stuff. And so I'm going to return them back more of those kind of things. But in terms of the storage on the front end, maybe MongoDB is probably best suited for that. I don't know. We'll have a play. I may do this on a live stream. Who knows? But yeah, that's my explainer for database schemas. They are a way of basically structuring data and structuring your database and making your database more rigid, essentially, and dealing with user access, dealing with the constraints, dealing with how the data is linked from one thing to the other. So yeah, that is that. And what I'll do is I'll probably write this as an article itself, and I've got a load of like resources on this too. But yeah, I'm gonna, as you can probably tell, my throat is getting worse, so I'm gonna call it, and I will see you again next time. Thank you ever so much for watching. Happy coding. And hey, one thing I haven't even mentioned yet, which I really should have done right at the start. This is a members only live chat. So if you want to consider supporting How to Code Well, and if you want to get involved in the podcast, then please do consider joining the members for How to Code Well. Also, when you do join, you'll also get early access to the podcast, because once this goes live, once the live stream is finished, I'm going to just set this to members only until it gets published in the audio form. But you also get you also get the tutorials that haven't been released yet. And also for the higher tiers, you also get all of the courses that I was showing you earlier. So you can access those for, without having to go through howtocodewell.net and paying for them. And as always, if you've got any suggestions for next content, if you've got any other questions or queries, then please do let me know either in the YouTube comments or go to howtocodewell.net/content and let me know there. If you've got any ideas for what you want to learn next, then that's all welcome. Thanks again, everyone. Happy coding, and I'm going to just rest my throat for the rest of the day. Cheers. Bye-bye. Bye.